At 7:50 p.m. Eastern Time yesterday, something erupted on the sun with enough force to dwarf every nuclear weapon humanity has ever built combined, and we couldn't see it. The blast happened on the far side, hidden from Earth's view, hurling billions of tons of superheated plasma into space at speeds exceeding 1 million miles per hour. But here's what should keep you awake tonight. That region is rotating toward us, right now, and in 72 hours it will be pointing directly at Earth. Welcome back. What NASA isn't saying loudly in their press releases, but what the data clearly shows, is that we may be watching the construction of a superstorm in real time. And unlike every solar event in human history before 2024, this time we have eyes on the far side of the sun. We're watching the monster wake up before it turns to face us. Let me show you what's happening up there. 2 days ago, the Solar Dynamics Observatory recorded a massive eruption designated as an M-class flare from an active region we cannot see from Earth. Under normal circumstances, that would be the end of the story. We'd mark it in our logs, watch for the rotation, and hope for the best. But these aren't normal circumstances. The European Space Agency's solar orbiter, positioned at a different angle in its orbit, had a perfect view, and what it captured has scientists using words like unprecedented and extremely volatile. The active region responsible is producing eruption after eruption. 3 major events in recent days, each one a massive release of energy. And according to data published just 48 hours ago by researchers at ETH Zurich, we're not dealing with just any sunspot region. This is NOAA 1364, and some of you watching this will recognize that number immediately. In May 2024, NOAA 13664 triggered the strongest geomagnetic storms Earth has experienced since 2003. Auroras danced over Texas. Radio communications across the Atlantic went silent. But more alarming were the cascading failures nobody talks about. Digital agriculture across the American Midwest ground to a halt. GPS-guided tractors stopped mid-field. Drones fell from the sky. Farmers lost entire days of critical planting season because satellites 400 miles overhead were being bombarded by radiation. And that was just a preview. Here's what makes this moment different from anything in the history of solar observation. For the first time ever, scientists have tracked a single dangerous active region through 3 complete rotations of the sun. 3 months of continuous monitoring, solar orbiter watching from one angle, SOHO from another, instruments on Earth filling in the gaps. They watched the magnetic fields twist and tangle like rubber bands wound tighter and tighter. They measured the energy building up, and now with that same region producing massive eruptions on the far side, they can see what's coming before it arrives. Dr. Louise Hara from ETH Zurich said something in the published study that didn't make headlines but should have. Even signals on railway lines can be affected and switch from red to green or vice versa. Think about that. A storm from the sun powerful enough to convince a railway signal that danger is safety, to flip traffic lights, to corrupt the electronic systems we trust with our lives every single day. But there's another factor that has space weather experts more concerned than they're saying publicly. Earth's Van Allen radiation belts, those protective zones of charged particles trapped by our magnetic field, are what researchers are calling fully charged. Throughout 2025, storm after storm pumped energetic particles into these belts. They're saturated, and when the next major solar blast hits, those particles could cascade down into our upper atmosphere in ways we've never observed before. NOAA Space Weather Prediction Center has already issued watches for January 17th and 18th, G1-level geomagnetic storms, they're calling them. Moderate activity. But here's what you need to understand. That classification assumes current conditions. If NOAA 13664 produces an X-class flare when it rotates into Earth view, if it hurls a coronal mass ejection directly at us at the peak moment, those G1 forecasts will be instantly obsolete. Now, I know some of you remember the Great Blackout of 1989, 9 hours without power across Quebec, transformers exploding, the entire province dark. That was caused by a solar storm hitting a power grid designed in the 1960s and 70s. Today, our grid is more complex, more interconnected, and paradoxically, more fragile. We've added satellite-dependent GPS timing systems that synchronize everything from financial transactions to traffic lights. We've made ourselves more vulnerable while believing we've become more advanced. The good news is, we're watching. Every instrument we have is pointed at that active region as it rotates toward us. Unlike 1972, unlike 1989, we won't be blindsided. Power companies have been notified. Satellite operators are ready to put spacecraft into safe mode. The systems are as prepared as they can be, but preparation has limits. Here's what I want to know from you, especially those of you who lived through the solar events of the past. Do you remember the auroras of 2024? The Halloween storms of 2003? The Quebec blackout of 1989? What did you see? How did it affect your life? And here's the bigger question. Are we more vulnerable now or better prepared? We have more technology, more satellites, more dependent systems. Does that make us safer or does it give us more ways to fail? Share your memories in the comments. Tell me if you think our increasingly satellite-dependent civilization can weather what's coming. In 72 hours, we'll know if this story ends quietly or if we're about to witness something that reminds us how small we really are. Until next time, keep watching the skies.